integral of the differentiation of the x squared plus 1 over the s equals to 2x. The integral of 3s over s squared plus 1 the s is equals to 3 over 2. Integral of the differentiation of the s squared plus 1 over the s all over s squared plus 1 the s. From the formula, the differentiation of the function of x over f of s, we now have 3 over 2 log in bracket s plus 1 plus c. Example 7. Evaluate the integral of 3s squared plus 4x all over 3s squared plus 2s squared plus 7 ds. Solution. The differentiation of the s raised to the power 3 plus 2s squared plus 7 all over the s is equals to 3s squared plus 4. The integral of 3s squared plus 4s all over s raised to the power 3 plus 2s squared plus 7 ds is equals to the integral of the s raised to the power 3 plus 2s squared plus 7 ds all over s raised to the power 3 plus 2s squared plus 7 ds, which will give us from the formula, which will give us log to the base e in bracket s raised to the power 3 plus 2s squared plus 7 plus c. Example 8. Find the integration of tan s ds. Solution. The integral of sin s over cos s ds is the differentiation of the cos s over the s is equals to minus sin s. The integral of sin s over cos s ds is now equals to, from the formula now, integral of minus the cos s over the s over cos s ds, which is equals to minus log the base e cos s plus c. Will give us log the base e cos s raised to power minus 1 plus c, which is equals to log the base exponential sec x plus c. Example 9. The integral of cos s ds is equals to integral of cos s over sin s ds. The differentiation of the sin s over the s is equals to cos s. The integral of cos s over sin s ds is equals to the integral of the differentiation of the sin s over sin s ds, which will give us log to the base exponential sin s plus c. Integration by algebraic substitution. If an integral is not in the standard form, it can be reduced to one that is in standard form by making an appropriate algebraic substitution. With example 10, evaluate the integral of s exponential s raised to power s dx. Solution. Let u equals to s squared. The u over the s is equals to 2s. The s is equals to 1 over 2s du. The integral of s exponential s ds is equals to the integral x exponential u times du over 2s, which is the same thing as half of integral of exponential u times du, which is equals to half of exponential u plus c, which is the same thing as half of exponential s squared plus 2. Example 11. Evaluate the integral of s squared cos s raised to power 3 ds. Solution. Let u equals to s raised to power 3. The u over the s is equals to 3s raised to power 3. The s over the u is equals to 1 over s squared. The s is equals to du over 3s squared. The integral of s cos s ds is equals to integral of s cos u times du over 3s squared. Is equals to 1 over 3 integral of cos u du. And for 1 over 3 sin u plus c, which will give us 1 over 3 sin s raised to power 3 plus c. Example 12. Evaluate the integral of s square root of 1 plus s squared ds. Solution. U is equals to 1 plus s squared. The u over the s is equals to 2s. The s over the u is equals to 1 over 2s. The s is equals to du over 2s. The integral of s square root of 1 plus s squared ds is equals to the integral of s square root of u du over 2s is equals to half square root of u raised to power half du, which is the same thing as half the integral of u raised to power 3 over 2 over 3 over 2 plus c. Therefore, 1 over 3 u raised to power 3 over 2 plus c. Therefore, when you substitute the value of u, we now have 1 over 3 in bracket 1 plus s raised to power 2 raised to power 3 over 2 plus c. Question 13. Evaluate the integral of s squared in bracket 3 plus s raised to power 3 in closing bracket raised to power 3 over 2 ds. Solution. Put u equals to 3 plus s raised to power 3. The u over the s is equals to 3s raised to power 2. The s over the u, that is, if you do the inverse, we have that 1 over 3s squared. Therefore, making the s the subject of the formula, we now have the u over 3s squared. Therefore, the integral of s squared in bracket 3 plus s raised to power 3 close bracket raised to power 3 over 2 ds is equals to integral of s squared of u raised to power 3 over 2 times the u over 3s squared, that is the s, which is now equals to 1 over 3 integral